Hey Becca, what are we learning today?
Today's lesson will cover the Pythagorean Theorem. A right triangle is any triangle where two of the sides form a right angle, which is 90 degrees. The side that's opposite of the right angle is known as the hypotenuse. The special characteristic about right triangles is that their sides have a relationship. A squared plus b squared equals c squared. This means that you can use any two values to solve for a missing value. This equation is known as the Pythagorean Theorem. In this example, our a is 3 and our b is 4, but we don't know what c is, so we can use the Pythagorean Theorem in order to find c. A squared, 3 squared, plus b squared, 4 squared, equals c squared. Let's reduce the left side a little bit. 3 squared is 9 plus 4 squared, 16, equals c squared. So now the left side, if you combine 9 plus 16, that becomes 25 equals c squared. In order to solve for c, we take the square root of both sides, square root 25, square root c squared, and this will give us c equals the square root of 25, which is 5. So now we were able to solve for the hypotenuse of this triangle, so c equals 5. In this example, our missing term in our triangle is b, but we can still use the Pythagorean theorem to solve for b. A squared, in this case our a is 6, plus b squared equals c squared, 9 squared. So let's square our whole numbers here. 6 squared is 36, plus b squared equals 9 squared, which is 81. If we want to isolate the b squared term, we can subtract 36 from both sides. B squared equals 81 minus 36, which leaves us with 45. In order to solve for b, we have to take the square root of both sides, square root b squared, square root 45, and this is going to leave us with b equals the square root of 45, which we can reduce a bit. Let's split up the 45 into factors 9 and 5. 9 is a perfect square. We could take the square root of 9, and that becomes 3, which moves to the outside of the square root. 3 radical 5. So we have solved for our b term in our triangle, and it equals 3 square root 5. In this last example, we have two missing terms, a and b, but we know that our c term is equal to 4. We also know that this is a right triangle, but it has two angles that are equal to 45 degrees. When a right triangle has two 45-degree angles, it is known as an isosceles triangle. Isosceles triangles have two equal angles, and they also have two equal sides. In this case, the equal sides are the sides that are across from the 45-degree angles. So b and a are equal sides. For simplicity, let's call them both a. So now we only have one term to solve for. All we need to solve for is a, and we can use the Pythagorean theorem to do so. Our a term is a squared, and our b term, which we're calling a, so we're going to square it, equals c squared, which is just 4 squared. Now on the left side, we have a squared and a squared. So that is 2 a squared. And that's going to equal 16. If we want to solve for a, first we divide by 2. Cancels on the left side. A squared equals 16 over 2, which is 8. In order to solve for a, we take the square root of both sides. Square root a squared equals square root of 8. So then a equals the square root of 8, which we can reduce a bit. Let's split the 8 into factors, 4 and 2. The square root of 4 is 2, and we can bring that on the outside of the radical sign and leave the 2 inside. So we found that a equals 2 root 2, and a is both of these sides. So we solved for all of the sides of our right triangle. After watching this video, I hope you have a better understanding of the relationship between the sides of a right triangle. But if you have any questions, you can leave it in the comments, and make sure you subscribe because I'm posting new videos every Monday and Thursday. Have a good day!